Welcome to update 0 of Zig-CLR project. So this update is going to be a little bit different from the other updates that I'm planning to do, in that what I'm mostly going to be doing is I'm mostly going to be walking through actually writing some code. It's going to be update 0 because what I'm doing is basically setting up a prerequisite for the Zig-CLR project. And what that what that prerequisite is to be able to, we have to modify the Zig compiler so that it will be able to redirect AIR, which is the intermediate representation of the Zig code, to a custom dynamically loaded SO program, plugin. So this is kind of the summary of what we're going to be doing. And so what's going to happen is we're going to create a new command line on the Zig command line that looks like this, and you set OFMT, and with a combination of those two compiler flags, you'll be able to run the Zig-CLR. Now, what I'll be demonstrating is how to create a new compiler backend. So another reason why I want to just do the full walkthrough of this is because it will, one, give you an idea of how the Zig compiler is architected if you're interested, and two, it will kind of give you an outline of how you would go about building a new compiler backend, at least in the current state of things. So let's get cracking. Before we go ahead, I'm going to show you a couple of quick shortcuts that I built that really help out in this process. So let's look at the Z shell script. And what this does is the Z shell script will run whatever Zig exists in the output of this fork of the Zig, and not the Zig that I have installed on my system. And I have B short for build, and what that does is it will rebuild the Zig code in this library. Now, the interesting thing is that we're going to be making changes both in the standard library that are then bootstrapped and used inside of the Zig itself, as well as in the Zig compiler itself. So in other words, what that means is that we need to point the lib directory to the lib directory that exists in here, instead of the one that the Zig that's rolled with my system would normally do. Okay, so let's get to work. The first thing that we're going to do is we're going to add these command line parameters out. So this is the command that we're going to want to test, and you can see currently it doesn't recognize the parameter fair_out equals foo.so. So let's build that one out. So we're going to add this new flag to source main.zig. So let's go to source main.zig. I'm going to split this over to the right so we can see what we're doing relative to our game plan here. So let's look and find for FLLVM. Okay, so what this section here is, this is in usage build generic function, I think. And what this is what happens when you run zig build exe help. So there's a big wall of text that you get, and FLLVM, this is right there. So what we're going to do is we're basically just going to first document these new things. So and let's also go ahead and add air to the OFMT documentation here. So here it is. Okay, so what we're going to do is we're going to build this. And then let's run the help command. And if you run the help command, you can see here we have fair_out equals path, and we have the air as OFMT. Now, of course, just adding this into the help file doesn't change the actual execution. So if we go ahead and do this, it still says unrecognized parameter. So let's add the argument parsing to near FLLVM parsing. So let's find FLLVM parsing again. Find. So here is where we check out the parsing for the command line. What was this? Else if. So we're going to want mem.starts with u8 arg and f air out equals. That's good. And then we want to set the create module opts dot air out equals. So in this case, what we need is we need to do arg, and then what we're going to do is we're going to slice past the boundary of where f air out is. Now the cool thing about Zig is that it lets you do this. And so this is a compile time known string, which is which courses to slice, and then we can .len that, and so this entirely gets turned into a single compile time known constant, and then we're going to go to the end. Okay, so if we try to build this, the problem is that create module ops doesn't have an air out. Right? And so as we build this, we're going to see no field name air out instruct compilation config.options. Now, this is going to wind up being a little bit out of order in some parts of this, because what we're going to do is we're going to trigger the compiler and then try to fix what the compiler says. So we may wind up checking off some of these items in our to-do list out of order. But in this case, that's not the case. We can go to source compilation config.zig. We're going to just click on that to get there. And what we need to do is we need to add air out as a parameter in this air out const u8 equals null. We're going to default that to null. And we also need to add the air out field to the options struct. So, well, actually, the next thing we can do real quick is we can build this, and we can just make sure that that will solve the unrecognized parameter error. Okay, so when we do this, now you can see it doesn't fail, right? It doesn't do anything, but it didn't stop and say something went wrong. And it just generates the normal foo.zig. By the way, is just something that prints out foo. And then if we do foo, it compiled and built what we expected. Okay, but if we build exe OFMT equals error, then we get a new error, and it says that error is not one of our available object formats. So we'll get to fixing that in a moment. Next, what we're going to do is we're going to add air out to the root. So this config struct here is a rooted struct. And so we need to add an air out. And we need to wire through this in the resolve function. So we're going to look for resolve. So here's a resolve function. And what this resolve function does is it takes like this options struct, which is what is immediately produced by the parsing of the command line, and turns it into like a more proper config struct, which is what that means is that if there are multiple different command line switches that have interactions, this is the spot where all of those are resolved, and the compiler makes a decision as to what to do. In theory, we should build some guards here to make sure that air out is set if and only if air is set, and OFMT air is selected. But we're not going to really bother doing that for now. And we are just going to go to the end of this and make sure that the air out field has been set. So we've been doing everything right next to use LLVM. So let's go ahead and do that. Dot air out equals options dot air out. So we're going to go to lib-standard target.zig and we're going to add the air variant to the object format enum. So let's go ahead and do that. And so now note that we're in the standard library at this point. So this is why here you need to have the library be recompiled as well as the compiler. So let's look at target.zig. Okay. And we need to add the air variant to the object format enum. Edit find object format. And here it is. These like to be kept alphabetical, so let's go ahead and do that. And then we need to add the file extension to the filex function. Okay, so let's try and build it and see what happens. Switch must handle all possibilities. So let's go ahead and do, okay, so this is the next one, which is to add the case in bin name alloc. And this basically is how Zig generates the binary name from the suffix. So let's just do this. We'll copy what we do in C for the C backend. Returns to dot. Let's just copy and paste this. Okay, so it looks like there's a couple places where we need to make sure we can handle all possibilities. And so let's go ahead and do this. This is whether or not something can handle a debug format. I think what we want to do is we want to put that under strip, so air. Okay, next. Link Zig, it needs to handle all the possibilities, and what we're going to do is we're going to just do .air, and this converts this standard target object format to a tag. We're going to have to deal with that tag in a bit. And then the last thing is unhandled. Okay, so switch must handle all possibilities here. LLVM does not support .air. So we're going to make sure that this doesn't accidentally trigger LLVM. Let's go ahead and build this again. Now we're going to have a problem where the tag needs air to be built in. We're going to deal with that in a moment. Okay, so here we go. So in link.zig, enum link.file.tag has no member named air. So let's go to, and the enum is declared here. So let's go ahead and do this. And then we're going to do air. I think we may want to like cut this off at some point so that we can actually just get a running compilation. Okay, so again, switch must handle all possibilities. Okay, so is this writable? I think we just want this to match what C does, and we are going to go, let's just make this unreachable. So air unreachable. We're going to change this in a moment. And then there's a few more places where we need to make sure we have link tags available. We just did that. Okay. So this may cause it to fail, but we're going to find out. We also need to add an air backend here as well, but let's not deal with that for the moment. Okay, so I think we've added it to all of the dev features. So let's see what happens when we try to build it. We did reach this comp time unreachable. All right. Let's go ahead and make this air. And right now, we don't have anything going on for this air. I'm going to hoist this up here. And let's see where C is defined. C is defined up here. Maybe not. Const C equals. Okay, so it's an import. So for now, we're going to do pub const air equals struct. We're just going to make an empty struct so that it satisfies the type. See if that causes problems. For errors. Okay, so we do need to go, in order to keep going on this, we're going to need to actually go through and build the link stuff. So let's go back to the list of things to do and just start adding all these things. So in file source dev.zig, we want to add air backend near LLVM backend. So here we have all the different backends. So here we have all the linkers. So maybe it's important to describe what the difference is between backends and linkers. So what a backend is it is what ingests air, which is the advanced intermediate representation that Zig initially compiles everything to, and then hands it over to the compiler for the compiler to do something with. That backend will then emit a struct called mir, which may or may not have to do with LLVM mir, but then that mir is sent over to the linker, and the linker is what stitches all these things together into a final executable or a library or whatever. In our case, we are just going to have a air backend. So let's make that. And the air backend will consume air and do the analysis on it and actually produce a error report. That error report will be stuffed into this mir struct. And the mir struct is going to be consumed by the air linker. And the air linker will just take the mir struct and turn it into some sort of it will turn it into like arbitrary code report for, hey, this is where all of the memory safety and or other correctness problems were found in your Zig code. Okay, so we added air back into the feature enum, so that's this thing, and then we need to add air back into the supports function. So what this is a function that, based on what your backend is, it will based on what your backend is, it will tell you what different things are supported, what development environments are supported in your development environment. So here we're going to want to add air backend for Bootstrap, and we're going to also add air backend to the core. Actually, I don't think we need this in the Bootstrap. Let's put that in front of C backend. I think we actually don't need this in the Bootstrap, so we're going to go ahead and delete this. And then we're going to repeat with air linker. So we just repeated that with both air backend and air linker. Great. Next, we need to be able to select the backend. So so what we're going to do is we're going to go to source.target.zig, and we're going to update the Zig backend. And here, all we're going to do is if target.ofmt equals .air, return .stage2 air. That's it. So what this means is if the format is set to air, as we did in our command line, we're going to return this enum, which will bundle together the compiler backend information. And then let's see, update has LLVM support. I think we already did that. Yep, we already told it that LLVM Air doesn't support LLVM. And then let's do backend supports feature. I think we also may have already done this, but let's see. Oh no, we have not. So this based on what the backend enum is. What are the things that it supports? So do we want to support panics? Yes. I'm going to put that right below C, right above C. Do we want error return traces? Yes. Do we want named enum values? I think. Do we want error set having values? Yes. Field reordering, I have no idea what that is, so we're gonna not bother. And the separate thread is generally true and only false for some of them. Okay, so excellent. So that's dealing with target and backend selection. Next, we need to create the CodeGen module. So what we're going to do is we're just going to, so this is the module that is, that contains the function generate, which is past the AAR. And that's effectively the implementation of our compiler backend. So we're going to go ahead and do that. And that is in source CodeGen air.zig. And the way we're going to do this is we're going to cheat. We're just going to copy c.zig and edit, paste. Okay, so we have a new one. And then we're just going to kind of gut this file and only leave the things that we care about. All right, so first, do we need legalized features? Yes, we do. So what legalized features tells the compiler is if you have the air backend, which of the features that Zig produces natively through, for example, built-in functions need to be broken down into other features in order to actually correctly compile. So that's what that is. And we're just going to copy that wholesale from whatever C gives us. Second, mirror is the entity that gets passed between the linker and the compiler. What we're going to do is we are going to go ahead and copy this for air. It's the air issues report. But we're just going to go ahead and leave this blank for now. Nothing in there. And then naturally this deinit is going to have nothing going on. So eventually this is going to have to contain a more sophisticated deinit and probably some sort of void pointer that will be bound in by the plugin. Okay, so we're going to have to do a lot of code pruning here. Okay, so for some of these bigger ones, I'm just going to delete them wholesale. And now we've gotten to this generate function. This is kind of the meat of what we're trying to do here. So what we're going to do is we're going to basically empty this out with the reminder that this is going to be incredibly important. Okay, so here, so we're going to make an empty mirror function or value. Don't need any of this. We're going to also going to fill this out with important stuff later, just to demonstrate that we are actually calling the generate function. Okay, so let's and I think generate is the only legalized features and generate are the only two functions that we need. So I think the rest of this can just all go. Okay, so next we need to wire the codegen module in. So let's go to src codegen .zig and add to dev feature for backend. I think we already did that. Nope, we didn't. So we need to add stage to air backend. And add to import backend. Next import backend. So here we need to do .stage to air import codegen air.zig. And then add to legalized feature switch. We need to make sure that is there. Stage to air. So this will basically just forward the legalized features into our into the function from our backend, and then add to any mirror union. So any mirror. So this also will bring the mirror struct into what we have. So so that adds us to the any mirror union. Then we need to add to the tag function air backend. So this is the any mirror. Here we go. Stage to air. I'll make that air. And then add to the any mirror DNet switch stage to air. And then add to the generate function switch stage to air. And that gets us to the point where we should be able to compile. Nope, we still need some linker involvement, but let's go and clear some of the things that we can clear. So error, no field name stage to error in compiler backend. So let's go take a look at this. So we forgot to add this. So stage to error equals 13. These need to be kept in order, and I think the numerical value is probably a thing we don't want to mess with. Arbitrary error to a plugin. Next, the type struct link.file.air has no member. So this is with the linker. So we're going to ignore all these linker problems. This is another link, no field name base and link file air. Great. Enum built-in compiler backend has no member name stage to error. So that we just resolved. So let's make sure that if we try to recompile, the only things left are linker problems. Okay, so looking at the problems, right, so this is a linker unimplemented problem. This one is maybe not a linker. Oh, this is a link file tag here problem. Link file error. Okay, great. So all of our existing problems are just needing to get the linker working. So let's go ahead and make the linker. And what we're going to do is we're going to go to source link. And then here we have a bunch of different linker backends. Basically what we're going to do is just like before, we're going to cheat and copy the C backend. Okay, so what we're going to do is first we're going to rename this C to air, and then we're going to replace all instances of cap C with air. Okay, next, we kind of really just want to get rid of everything, maybe except for base. I think base is the only thing that we need to do. And we do want to substitute for open. Let's just return, oh, so we just need to return an error. So what we need to do is we need to return something that looks like this. So this will basically just give us a maximally useful error file. We also removed a whole bunch of parameters from air. So we're just going to delete these guys. We don't need these. However, the one last thing to do I have here is make sure that the .tag is air. So we need to make sure that that is that. And air file. Okay, so that should do it for the open function. For create, we don't need dinit. Well, we do need it, but we don't need anything in there. That's a no-op empty. So let's do this. Self. We also are going to no-op empty the update function. We also don't need this function at all. We need to no-op empty the update nav function. This one returns void, so we're probably fine there. Update line number, doesn't need to do anything. ABI defines, we're just going to delete that. Pub function flush, we do need to no-op empty the flush. We also don't need this flush struct. We do need to update exports. We then need to wire the linker module in. So in source link.zig. Here before we had this empty struct, which is no longer good. So we're going to import link error.zig. And I believe that will satisfy quite a bit of the problems. Still 4 errors. Okay, so there are some issues here. So in error.zig, use of undeclared identifier optimize mode. Use of undefined identifier file 47. Undefined identifier prod node. prog node. Let's tackle this one too. Root struct of root source file struct link air has no member create empty. Create empty. Huh. Did want a create empty. Okay, some new errors. And most of these appear to be switch must handle all possibility errors. So let's go ahead and do that. So we're not handling stage 2 error here. Const backend okay. So stage 2 error true. Let's do it here. Link.zig650. Switch base tag. This is going to be, we're going to do air gets air linker. And I believe what check any does is that a compile time matches up these with the same one with the linker appended. Next, no field name stage 2 error in built-in compile stage 2 error, and no field or member function name get nav vadder and link.error. So let's go ahead and just copy that. Find get nav vadder. We need to make this air unreachable. No field or member named lower UAV. Did we need to wire that in there? Okay, so why are we getting a lower UAV here? We need to make this dot air unreachable. So this is for functions that need to dispatch on tag, add air backend cases. Some will be unreachable, some will need actual handling. Review each switch on base.tag and decide. Okay. No field or function name get UAV adder. Again, this should be unreachable. And that looks like it. So let's go through the last few bits of this. And compilation config, file source compilation config. So compilation config. And we need to make sure add to the debug format resolution strip. So we did that a while back. We want to add calling convention support to src zcu.zig. srec zcu.zig. That's here. And we need to do callcom supported. Yep, so we already did that, and we're just basically saying it true, except all calling conventions. Great. POSIX compatibility, lib std posix.zig. Update DL iterate PHDR. Great. And this we need to add in switch built-in object format dot air. Okay, so let's rebuild this, and then we're going to run and see what happens and see if it accepts our parameters and doesn't output a Zig executable. So next we're going to rm foo. And then let's do z build exe fair out equals foo.so o format equals air foo.zig. And it's going to attempt to compile this, and nothing should be outputted because we sent it to the air compiler instead of the normal Zig compiler. So lsfoo, and it's not there. Excellent. If we omit these, right, we're going to wind up just with the normal foo. Okay, so that is working. And the one last thing that we kind of want to do is to really just kind of show you that, in fact, we have built in a compiler, that we have built in the code gen to handle what's going on. So I have some pre-baked code that I'm just going to copy paste in here that will just help us out. In brief, basically what it does is, this is a per thread ZCU. It's going to grab the ZCU that's native to whichever thread is running the code gen on this. Then it's going to grab the intern pool, which is the basically, if you're familiar with how games do this tables of of common objects so that they're all stored in a single interned set of values. That's one of the speed tricks that the Zig compiler uses. It's got this thing called an intern pool, and so that retrieves that from the compiler unit. From the compiler unit, we can grab function info for the function that we're being told to generate, right? And then we grab the nav from the same ZCU function. And the important thing is the nav contains the fully qualified name. And so we're going to be able to use that and say we are analyzing function named s, the fully qualified name. And while we're at it, we're just going to show that we're going to be sending it to whatever our air out .so file is. So let's go ahead and recompile this and then run this. And so here we're going to run the build command with the air out to this .so file that we haven't really created yet and aren't actually dynamically loading, but just to demonstrate that we know what we're looking at. And then our format is air, which will trigger us to go via the air analysis compiler backend. And as you can see, it is going through every single function that is necessary to create the foo.zig executable and saying, hey, I'm reading this function and I'm sending it to foo.so. And that's it. Basically, at the end of all this, what we have done is we have instrumented the Zig compiler with a new backend, and this new backend is what we're going to use to do air analysis and get memory safety in Zig. So if you like what I'm doing, please like and share this video. I know it's kind of long and very nitty-gritty. And if you're excited about memory safety in Zig, feel free to sponsor me through my Buy Me a Coffee link. Thank you very much.